3.
3.
Number 3, we have a given. Let's say U is equal to the set 1, 2, 3, 4, 5. A is the set 1, 2, 3, and B is the set 2, 3, 5. Then, A complement are those elements of U which are not in A. So, what are those? So, we have 4 and 5. While the B complement are the elements at U but not in B. So, what are those? So, cancel 2, 3, 5. So, the remaining is 1 and 4. So, now let's have functions and relations. So, a relation is any set of ordered pairs. A function is a relation in which no two distinct ordered pairs have the same first element. So, how to recognize that a given function is not a function, or a given relation is not a function? So simply, the first one is when each graph crossed by a vertical line in at least 2 points. So looking this graph, the vertical line passes through 2 points. So this is not a function.
Captured.
While this one passes only through 1 point. So this is a function.
Ano ba to? Nasa US pala yan. Wala. Nasa US.
Another way to find out when a particular relation is not a function or there still when an x coordinate of a point when an x coordinate of a point in the set of ordered pairs has at least 2 y coordinates.
Tapos ano ba to? Nasa
when y has an even exponent in an equation except when equated to 0, when y is enclosed in absolute value except when equated to 0, when y is absent from the equation, and when the statement is an inequality. I have a correction on the last part with my example given in your module. So that should be equal to make it not a function. To make it a function. Next, in the functions, we will never forget the domain and the range. So the domain of function is the set of all possible values for x for which the function is defined. So the range of the function is the set of all possible values of y for which the function is defined. So I have examples. So I have 5 different examples. The first one is using an ordered pair. Okay. So to get the domain, just copy the first or the x value. To get the range, copy the y values. Since 1 is repeated, then you can simply write it once. In the graphical presentation, just to get the domain, locate for the x-axis. So as we can see, the graph in using the x-axis, it's within -3 to +3. So that's why x is greater than -3, but less than 3. To get the range, simply get the height of the graph, looking at the y values, from the bottom going to up. So the y is between -2 to 4. So that's why y is greater than -2, but less than 4.
4.
Okay, number 3. This kind of example is what we call a rational expression. Rational equation. So in this kind of example, we try to make our equation undefined. How do we make an equation undefined? So if your denominator becomes 0, then your equation is already undefined. In short, what are the values of x that makes your denominator 0? We will try to avoid those. Okay? So this one, to get your domain, so you simply equate your denominator with 0. So x plus 2 is equal to 0. So x is equal to negative 2. So what is x equals to negative 2 means? Meaning, the x equals to negative 2 is the value of x that makes your equation undefined. And we do not want negative 2. Therefore, the values of your domain are the values of x
Equal.
are everything, are all real numbers except negative 2. Pwede lahat ng x maliban kay negative 2. Why? Kapag negative 2, ang value ay undefined. Bakit naging undefined? Because yung denominator mo ay magiging 0. Pag sinubstitute natin yung x, is equal to negative 2. Negative 2 plus 2 is 0. Ayaw natin yun. That will make our equation undefined. So, pwede lahat maliban kay negative 2. How about for the range? So, for the range, first interchange x and y. Okay, interchange. And then solve for y. By doing so, we will find out that y is not equal to 3. So, it's the same meaning. Your range can be all real numbers except 3. Number 4 and number 5 is what we call a radical equation. Okay? So, a radical equation. So, if you remember with the parts, we call this radicand. And here is your index. The index of unknown index is, that implied index is always 2. This has an index of 3. So here, what we're trying to avoid, what we're going to avoid in the radical equation is to make the radical part imaginary. The imaginary has a value of negative 1. Or simply to make it negative. Ayaw natin maging negative yung ating radicand. Iiwasan natin yon. Okay? So, you equate your radicand. In our example, x minus 3 greater than or equal to 0. Ma'am, why greater than or equal to 0? Because this is always positive already. 0 is not negative. Greater than 0 are already positive. So, in short, naiwasan na natin si imaginary. Okay? So, by doing so, we found out that x is greater than or equal to 3. What does it mean? So, the value of x, your domain is the set of all x's greater than or equal to 3. Ma'am, kasama po ba si 3? Yes po. Because 3 minus 3 is 0 and square root of 0 is 0, not imaginary. Okay?
Isa ka dyan. Pili pa.
And the range, if we're going to have these radicals are also known as fractional exponents. So if we're going to look at that, the graph of this is, it doesn't go down lower than your x-axis. Lagi lang siyang magta-touch sa lower axis. So the y of that is 0, going up, including 0. So that is 0, positive infinity. So, ma'am, what is the difference between your example on numbers 4 and 5? So, ang pagkakaiba lang nito, look at the index. This is even, this is odd. And the inside radicand is negative, or the minus, okay? So, if you have like this, and this is odd, it's obviously your domain is all real numbers. Same with your range, all real numbers. So, how do we evaluate an operations on functions? So, to evaluate the functions, we simply substitute the value of the given x So this is read as f of x. So for example, you are asked to evaluate f of x is equal to x squared plus 2x minus 3 all over x minus 3 at x is equal to negative 3. So first you're going to do is to substitute negative 3 on all the x given. So kahit dito, papalitan yan. Typo. So and then,
Na X.
the value of x is negative 3. So f at negative 3, okay, substitute all x with negative 3 and then execute the operation. And we found out f at negative 3, f of negative 3 is 0. Okay, next. So for this one, we have operations on functions. Okay, so this is the operations and this is the example executed. So in the addition operation, so we have f plus g of x is equal to f of x plus g of x. Ito yung pinaka theorem. Ito yung execution. Okay? Ito yung operation. So f plus g of x can be executed as f of x plus g of x. While f minus g of x is equal to f of x minus g of x. Napupunan natin, no? We are distributing x. Okay? F of g of x is equal to f of x times g. While f over g
I-disinfect natin to, mga kaigan. Babalikin mo lang.
of x is equal to, excuse me,
Ito naman natin mga kaigan, di ba? Yes. Pero pang kalagay din dyan. Yes.
ma'am, sir, pasuyo naman kami.
Hindi kaya sa yan, mga kaigan.
Hello?
Sana all mandirigma.
Guys, kindly double check kung nakamute kayo. Salamat po. So, f over g of x is equal to f of x over g of x. So, to understand this, we have, for example, f of x is equal to 2 plus 1 and your g of x is equal to 2x squared plus 3x plus 1. So, if we're adding, so we know that when we add polynomials, so we're going to add similar terms. So this one doesn't have something to add with. So combine 2x and 3x and combine 1 and 1. So the final answer is 2x squared plus 5x plus 2. You have to arrange the polynomial according to their degree. So in subtraction, again, so f of x, this is f of x, so minus the g of x. The same thing, so subtract, the answer is negative 2x squared minus x. So I guess you know this one, multiplication, we have the distributive to distribute, right? Remember, if you remember. And then combine similar terms. And then don't forget to arrange the terms in decreasing manner. In the division, so we have this. We can cancel this one. So the remaining is 1 over x plus 1. So that is how. So the next concept, we are now on our third concept. We have the unary operation and the binary operations. A unary operation accepts only one value or operand. So examples of unary operations are here. The negative and the positive here are just symbols of the negative. Hindi siya minus 8, hindi siya plus 25, but they are just the symbol for negative and the positive. For the binary operations, let's say take two real numbers, perform operation on them, and produce another real number. So that is what we are doing if we have binary operations. And the usual or the common binary operators include the following. These are the common binary operators. So, ito yung plus, hindi to positive, this is operator plus, this is minus. So, these are the usual. Okay, next, so we have examples of binary operations. These are operators. Operations, so we are doing it in the process already. So, 4 plus 5 is equal to 9. So, we have plus here. We have two real numbers and produce another real number, 9. So, these are examples of binary operations. So, what are the properties of binary operation? So, we're going to take only operations. We have the addition and multiplication. So we have the closure of binary operations. The product and the sum of any two real numbers is also a real number. Okay, let's take the product first. So for example, sum of two real numbers. Okay, so 5 is an 5, let's say 5 and 2. 5 and 2 are both elements.
ICCT.
So 5 and 2 are both elements of real numbers. When we add, okay, 5 plus 2, which is equal to 7, we know that 7 is also an element of real numbers. So therefore, this is an example of addition under closure of binary operations. Same true with 5 times 2. 5 and 2 are element of real numbers, producing 10. And 10 is also an element of real numbers. Okay? So those are examples. And there are still examples in there. The examples in there I gave you in your module is, for example, sets of natural numbers. When I say natural numbers, it's the same as counting numbers. So the product and the sum of any two counting numbers is still a counting number. Do you agree? Let's assume, counting numbers, the product and the sum of any two real counting numbers is also a counting number. Okay, 2 and 3 are counting numbers. Agree? So 2 plus 3 is equal to 5. 5 is a counting number. 2 times 3 is equal to 6. And 6 is also a counting number. Therefore, this is an example. This is closed under binary operations. Next, commutativity of binary operations. So here, the positions of the numbers or the operators or the variables does not affect the value. For example, we have x is equal to 8 and y is equal to 9. 8 plus 9 is equal to 17. And of course, 9 plus 8 is equal to 17. We notice that 8 here is the first number, while here is 9 is the first number. So the order of the numbers does not affect the output. Associativity of binary operations. So example, x is equal to 4, y is equal to 5, and z is equal to 6. So we can see it here that if you will add first 4 plus 5, and then add with the 6, with the sum of this, add with the 6, is the same as, the result is the same when you add first 5 plus 6, then add the 4. That is the same answer, 15. Same with true with multiplication. For the distributivity of binary operations, so let's say x is equal to 2, y is equal to 5, and z is equal to 4. So, if we're going to have 2 times 5 plus 4, that 5 plus 4 is 9, times 2 is 18. That is the same as when you distribute 2 first. So 2 times 5 and 2 with the 4. 2 times 4 is 8. 10 plus 8 is also 18. So let me finish this one. The binary operations. Identity elements of binary operations. For example, we have x is equal to 7, equal to 7. And 7 times 1 is equal to 7. So the identity preserve the value of the given variable. Therefore, the identity element in addition is 0, and the identity element in multiplication is 1. That preserves the value of the given variable. And the value of our given variable is 7. Next, we have the inverses of binary operations. So, for example, we have x is equal to 5. To get the inverse, so just get the additive inverse. Let's say the additive inverse of positive is negative. And the result should be the identity element. So, 5 plus negative 5 will give you 0. And for the multiplication, get the reciprocal. What's the reciprocal of 5? 1/5. So, if you're going to multiply these ones, it's equal to 1. And 1 is the identity element of multiplication. Okay, I will start this for this one, some fundamentals of logic. So that will be on the next meeting. I will be giving the rest of the video. I'll be doing the video of the whole module 2 and post in our Orange app. We are on week 4 already. When is our exam again? September 15.
22 po.
22 po.
22 po.
Okay, September 22. So, kapag wala tayong make-up class, kasi ang coverage, nakita niyo na po yung ating course outline, correct? Nakita niyo po?
Yes.
Okay. So, our course outline, we have 3 modules for this premium. Pero nakaka 2 modules pa lang tayo. And we have only 1 left. May 22. Anong date sa Monday?
14 po.
So Monday is the 5th week. And then 21 is Monday ulit, correct?
Opo.
Yes.
14 plus 7. So, okay, so may dalawa pang meeting. Start ng exam ay 22. Correct? Tama ba? Exam start yun?
Opo.
Opo, ma'am.
Opo. Sa makakapag-class pa. Okay, so next week we will be having module 3.